Hello, we all know that sand absorbs water quickly. If you're in a desert area and you pour some water on the sand, it will soak it up in seconds. Even if you bring a whole truck of water and dump it on the sand will still absorb it quickly. Sand is very strong in absorbing water. But wait a second. Oceans and seas have a lot of sand underneath them, so why doesn't this sand absorb the water? How come the water in large bodies like lakes and oceans never runs out, especially isolated lakes? We've all seen a huge lake literally in the middle of the desert, and yet it still has water to this day. So what's the story? Welcome to Ask Away. But before we start, if you're new to the channel, don't forget to subscribe and hit the bell icon to get our latest videos. When we look at any beach, we see that it's covered with a huge amount of sand along the coastline. This raises the question, where does all this sand come from? Contrary to popular belief, the sand on beaches doesn't come from the seabed. The main source of beach sand is the weathering processes that occur on rocks on land around the beach area. The constant ebb and flow of tides in the sea cause waves to hit the rocks on the shore, leading to their erosion. Over time, these rocks gradually break down into smaller particles. In addition to wave action, other factors like wind, ocean currents, rain, temperature changes, and more contribute to the breakdown of rocks near the shore. These rocks erode and accumulate along the coastline as sand. This process takes place over thousands and even millions of years. In short, beach sand is essentially eroded rock, particularly from the surrounding area. This is why the sand on different beaches varies in color, type, and texture. Some beaches have brown sand, while others have pink, white, yellow, or even black sand. The color and composition of beach sand are linked to the types of rocks in the surrounding area. For instance, most beaches worldwide have sand that ranges from yellow to brown due to the presence of feldspar minerals, which make up around 60% of the world's rocks. Additionally, quartz is a common mineral in most rocks, which when eroded produces sand of varying shades from yellow to brown. An example is Papakolea Beach in Hawaii, where the sand is green due to volcanic rocks containing olivine, a mineral made of magnesium and iron silicate. Meanwhile, Punaluu Beach in Hawaii has black sand because of the basalt rocks around the beach. The gist of what we're saying is that sand is usually found on beaches, not on the ocean floor. Most seas and oceans don't have sandy bottoms. The sand is mostly on the surface. The amount of sand on beaches is minuscule compared to the vast amount of water in the seas and oceans. Thus, sand can't absorb or deplete this water. Sand has a limit to how much water it can absorb, and once it's saturated, it won't absorb any more water. Regarding the ocean floor, don't let anyone tell you otherwise. Sure, you might see some pictures showing sand on the ocean floor, but even if a bit of sand makes its way to the bottom, it's usually very little and doesn't significantly absorb the seawater. Usually, these sandy areas are specific, and if we look at the materials covering the ocean floors, we'll find most of it is mud, with sand making up a very small percentage. The mud or other sediments on the ocean floor aren't very deep, and right beneath them, there's a solid rocky layer that's part of the Earth's crust. This layer is very hard and impermeable to water, lining the entire ocean floor and preventing water from seeping into the lower layers of the Earth. Besides the impermeable layer at the bottom of seas and oceans, there's the natural water cycle that compensates for any loss of water. The water cycle has no specific starting point, but a good place to begin is the ocean. The sun heats the ocean water, turning it into water vapor. The vapor rises until it reaches cooler layers of the atmosphere, where it condenses and forms clouds. Winds then move these clouds across the Earth. When the clouds get heavy, they turn into rain, some of which falls back into the ocean, some into rivers and lakes, and some freezes as ice. When the ice melts, it flows back to the Earth. Some rainwater infiltrates the soil and gets stored as groundwater. but most water bodies are connected and eventually drain back into the ocean. Even isolated areas with limited water stored in the soil have plants that absorb the water through their roots and release it back into the atmosphere through transpiration. So if the sand on beaches absorbs some seawater, it will evaporate and fall again as rain. This cycle keeps the seas and oceans constantly full of water, maintaining a relatively stable water level over thousands of years. However, scientists predict that ocean levels will rise in the future due to increasing global temperatures, causing polar ice caps to melt. The melted ice will contribute to the rising sea levels. Nevertheless, water bodies are far from drying up because of sand. Let's take a more complex example: isolated lakes or seas in the desert. What's their situation? Take Lake Karun in Egypt, for instance. It's one of the oldest natural lakes in the world, millions of years old, yet it still has water today. And it's in Egypt, a dry country. How hasn't the surrounding sand absorbed its water? As we explained, lake bottoms don't necessarily have sand, even if the lake is surrounded by it. The bottom is usually solid rock that doesn't let water pass through. This is the case with Lake Karun, otherwise it would have dried up long ago. The real problem with a lake like Karun isn't the sand. The main issue is the water supply. In the past, the lake was fed by the Nile's floodwaters. Being about 60 meters lower than the Nile's water level, there was a waterway directly connecting the lake and the Nile, filling it with a significant amount of water. However, over the centuries, as the Nile's water level decreased, the connection was severed, greatly affecting the water supply to the lake. Nonetheless, the supply didn't completely stop. There's a narrow waterway called Bahr Yusuf, which still feeds the lake from the Nile via a governorate along with several agricultural drainage canals. Without these supplies, the lake would have dried up long ago. Hence, Lake Karun has shrunk over time due to reduced supplies, not because of the sand. That's it, we're done. Made it this far. All of you are the best. Give us a like so we can see how many people made it here. And if you have any questions, don't forget to write them in the comments.